Space, the final frontier, is far bigger than you ever were told in school. Let's start with a simple yet staggering fact. Space is unimaginably vast. We often think of the moon as being far away, but in the grand scheme of our universe, it's practically next door. The distance from Earth to the moon is a mere 238,855 miles. That's about 10 times the circumference of our planet. A daunting distance indeed, but just a hop, skip, and a jump in the cosmic perspective. Now let's venture a bit further. Our nearest neighboring star, Proxima Centauri, is approximately 4.24 light-years away, but what does that mean? To understand this, we need to grasp the concept of a light year, the astronomical unit of measure that illustrates just how enormous our universe is. A light year is the distance that light, traveling at a speed of about 186,000 miles per second, covers in a year. That's a mind-boggling 5.88 trillion miles. To put that into perspective, if you were to travel at the speed of light, it would take you about 1.2 seconds to reach the moon. But to reach Proxima Centauri, it would take you the better part of 4.25 years. Just imagine if you were to travel the distance to our nearest star at the average speed of a commercial jet, it would take you about 5 million years. Yes, you heard it right, 5 million years. And yet Proxima Centauri is our closest neighbor in the cosmos. Beyond it lies an expanse so vast that it defies comprehension, filled with countless stars, galaxies, and mysterious dark matter. So when we say that space is vast, it's not just a statement, it's an understatement. It's a reminder that we are but small specks in an infinite cosmic arena. And that's just our closest neighbor. We're just at the beginning. Now let's talk about our home galaxy, the Milky Way. Imagine a bustling city teeming with life, stretching out as far as the eye can see. Now multiply that by 100 billion. That's the estimated number of stars in our Milky Way. From tiny, cool red dwarfs to colossal, blazing blue giants, these celestial bodies light up our galaxy with a luminosity that's simply awe-inspiring. But the stars are just part of the story. The Milky Way is a barred spiral galaxy, with a diameter spanning a staggering 100,000 light-years. To put that into perspective, if we were to travel at the speed of light, a mind-boggling 186,282 miles per second, it would still take us 100,000 years to cross from one side of our galaxy to the other. That's a journey so long our early human ancestors would still be roaming the Earth when we set off. Now, if the sheer size of our Milky Way has you reeling, brace yourself. Our galaxy is far from being the only one out there. In fact, it's estimated that there are around 2 trillion galaxies in the observable universe. Each of these galaxies, like ours, is a swirling mass of stars, gas, dust, and dark matter. From dwarf galaxies with just a few 100 million stars to giant ellipticals home to an estimated 100 trillion stars, the scope and variety are breathtaking. And each of these galaxies is separated by vast expanses of intergalactic space, distances so vast they're measured in megaparsecs, where 1 megaparsec equals about 3.26 million light-years. So let's take a step back and marvel at the magnitude of it all. Our home, the Earth, is but a speck of dust in the grand cosmic scheme. Our Sun, merely one star among hundreds of billions in our galaxy. And our galaxy, the Milky Way, just one in a cosmic ocean teeming with 2 trillion galaxies. Just imagine our Milky Way is but one of possibly 2 trillion galaxies. So how big is the observable universe? Brace yourself. Picture a sphere so large that it's virtually impossible to comprehend its true size. This sphere is the boundary of our observable universe, and it has an estimated diameter of 93 billion light-years. Yes, you heard that right. 93 billion light-years. This is the distance that light, traveling at a speed of approximately 186,000 miles per second, would cover in 93 billion years. Now, let's try to grasp the enormity of this number. If you were to travel at the speed of light, it would take you about 1.5 seconds to reach the moon. To reach the sun, it would take about 8 minutes. Now imagine traveling at that speed for 93 billion years. That's the diameter of the observable universe. But the universe isn't just vast in terms of space. It's also incredibly vast in terms of the number of particles it contains. Current estimates suggest that there are approximately 10 to the power of 80 atoms in the universe. That's a 1 followed by 80 zeros. To put that into perspective, that's more than the number of grains of sand on all the beaches on Earth. Every single one of those atoms is a part of some star, planet, galaxy, or other celestial object. And each of these celestial objects is part of a galaxy, and each galaxy is a part of the universe. The scale is truly astronomical. So when we talk about the universe, we're talking about a space so large and a number of particles so huge that it's virtually impossible for our human minds to truly comprehend. We're talking about billions upon billions of galaxies, each filled with billions of stars. The universe, with its billions upon billions of galaxies, each filled with billions of stars, is truly mind-boggling. Opening. Yet everything we've talked about so far, all that we can see, it's just a fraction of what's out there. As we delve deeper into the cosmos, we encounter a universe shrouded in mystery and intrigue. This is the realm of dark matter and dark energy, cosmic enigmas that make up a staggering 95% of the universe. Dark matter, an elusive substance invisible to our current instruments, was first hypothesized due to the gravitational effects it seemed to exert on galaxies. Despite our inability to observe it directly, its presence is inferred by the way stars, galaxies, and clusters of galaxies move. Imagine a cosmic ballet where the dancers move in sync to an unseen rhythm. That's dark matter for you, the unseen choreographer guiding the dance of celestial bodies. On the other side of this cosmic conundrum is dark energy, an even more mysterious phenomenon. This is the strange force that's causing the universe to expand at an accelerating rate. It's like watching a balloon inflate, but with no visible source of air. Picture this. You're in a car, foot off the gas pedal, yet the car continues to speed up. That's what dark energy does to our universe. But here's the kicker. We don't really understand what dark matter and dark energy are. They are placeholders, terms we use to describe phenomena we can't yet explain. We're like a detective piecing together clues, trying to solve a cosmic whodunit. Despite our best efforts, the universe keeps its secrets well hidden. Our most powerful telescopes and most sophisticated theories can only scratch the surface of these enigmas. We are in many ways still at the beginning of our cosmic journey, venturing into the unknown, grappling with mysteries that defy our understanding. Closing. So, everything we've discussed, all those mind-numbingly huge numbers, they only represent about 5% of the universe. To wrap up, let's bring it all together. We've traversed the vastness of space, from the billions of stars in our own Milky Way to the estimated 2 trillion galaxies in the observable universe. We've delved into the enigmatic darkness where dark matter and dark energy continue to baffle even the most brilliant minds. The numbers are mind-boggling. 100 billion galaxies, each home to hundreds of billions of stars. A universe that extends for 93 billion light-years, filled with celestial bodies we're yet to discover. And let's not forget the dark universe, a realm of unknowns that comprises about 95% of the cosmos. The scale is staggering, the numbers astronomical. It's a cosmic dance of epic proportions, a testament to the magnificent enormity of the universe. So, next time you look up at the night sky, remember, space is far, far bigger than you were ever told in school, and we're still learning just how staggeringly vast it truly is.